Okay, so that is electric field. How about potential? What's electric potential? Electric potential, know the word definition. The definition is the work done per unit charge to bring a positive test charge from infinity to a certain location. All right, let's break this down. What's work done? Work done is the amount of work, change in work, to what? To bring it from infinity to a given location, but per unit charge, right? Per unit positive test charge. So per unit charge. This is the definition of what potential is. Break this down a little bit more. What's work done? Work done is force times distance, right? So force times, let's say the distance is, it brings a certain length. So from infinity to point R, that's work done per unit charge. Of course, you see that force per unit charge is electric field. So you can make a much easier formula, actually not easier, but more practical formula like this. So this is the definition of absolute potential. Okay? Actually, no, this is the definition of absolute potential, but this is a useful formula for it. Okay? So this is actually very useful. If you know electric field, you'll know the potential, right? If you need potential difference, let's say between point A and point B, like this, then what you want is you integrate from point A to point B. Infinity is the reference point, right? So if you just want the difference, you use this formula. If you want the absolute potential, then you always start from infinity to that point. If you want potential difference, you start from the initial point and end up in your final point like that. A quick example, let's say I have electric field like this over here, and the electric field is something like 3x plus 4y in the positive x direction. Okay? Let's say it's in, I'll use this notation, positive x direction. Okay. So let's say I want the potential difference between point A and point B. Let's say this is 3, 3. I'm just making up these numbers. Let's say 1, 2 like this. How do I do it? I want the potential difference between A and B. So you write A, B, electric field, and the length. Okay. What is A? A is 3, 3. Okay, so let me just write A and B to save some ink. The electric field is 3x plus 4y in the x direction and 0 in the y direction, right? So I don't need to write that. Dot, what's dl? dl is the length. Well, L is the length over here. DL is a small distance between A and B. So it's made up of a small distance in X and a small distance in Y. So this is the X over the Y like that. So it's a small unit in the X direction, small unit in the Y direction. So do the dot product. So that's 3x plus 4y dx plus 0 dy, right? That's how you do dot products. You multiply this together and add them together. 0 dy, we don't have to write that. Okay, so when you integrate this, what's integrating 3x? Well, it's 3 over 2x squared plus, as far as the integral of dx is concerned, y is a constant. So all you have to do is for y, that's a constant, just multiply x like that. Okay. And then now you need to plug in the numbers. How do you plug this in? So a is 3, 3, b is 1, 2. So now you plug it in. So you plug in b first, in the first term. What's x? What's the x value of b? It's 1. And 4, what's the y value of b? 2. What's the x value of b? 1. Minus, and then plug in everything from a. So what's the x value of a? 3. What's the y value of a? 3. What's the x value of a? 3. And then you do the math. That's your potential difference. So that's all I have to say.